All right, we are live. Hello, everybody, and welcome. I hope everybody's doing well tonight. We are going to pick up the stream where we left off last night, implementing tonight our format that we kind of designed last night, which is this K3D format. So that's what we're going to do tonight. Before we jump into that, though, I do want to just take a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Olazaran, followed by our partners Gobolis Inc. and Matt Oscard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. I greatly appreciate it, and it helps me cover costs associated with running this channel. So it covers things like software licenses, hosting fees, occasional hardware, things like that. And eventually it'll help me pay for any assets I'm not capable of generating myself for the game project. So thank you all very much for that. It is greatly appreciated. In addition to that, I would also like to extend a large thank you to all of you, the viewers, whether you're joining us live here on the YouTube side or on the Twitch side. Without you guys, this project and this channel would not exist. So thank you guys very much for being here. I greatly appreciate each and every one of you. That being said, let's catch up with chat real quick. That guy, Doro, good to see you. We're actually not early tonight. I'm actually starting a little bit late. But yeah, thank you for being here. Penguin Operator, rather. Good to see you as well. Shikama, hello. Are you early enough this time? Came when you left before. Yeah, so we're just getting started now. Skyube, wow, Scicube, dyslexia hit me hard there for a second. How's it going? Why introduce this format? Fair enough. You mean as opposed to using like a existing one like OBJ or GLTF, something like that? So, a couple things. This whole exercise is showing a way of creating a game engine from scratch and all the things that go into that. And so it's designed to be sort of an educational resource. And so we are diving into things like this to help gain an understanding of how you might build something like this from scratch. So that's one reason. But the main reason is we want to have a format that is close to what the engine already expects so that we can very quickly load this. We don't have to do any parsing in the file per se. We can just load all the binary data and have it ready to go. We don't have to do a whole lot of processing or overhead trying to read in that file. We want it to be as quick and painless to read in as possible. And so this is one of the ways that we do that is we store the data in a format that the engine understands, or at least something very close to that with minimal processing required. So those two reasons are the primary reasons for doing that. And like I said, this is an educational resource. So, I think it's good to, kind of go into things like this. The other thing that this is going to do, or we're going to include rather, is not only are we going to be reading this in, but we are also going to be writing an exporter eventually in Blender to export directly from that to this format. So we're going to see how to do that at some point, probably not anytime soon, but at some point we'll be doing that. But for now, we're going to have essentially a command line converter to convert from, GLTF, Collada, OBJ, those kinds of things to this format as well. So we're going to see sort of that whole process, from end to end there. If this had been probably 15 years ago, I'd probably be doing it in 3D Studio Max instead of Blender, but here we are. So yeah, I hope that answers the question. Singy over there on the YouTube side, hello, how's it going? Hope you're doing well. Okay, so the way that we're going to handle this is the very first thing that we have to do is process the header, which should be relatively straightforward. I think for the most part, we can actually just read in this memory straight into a structure. And And that should really be it, right? So this part is going to be simple, but it is going to give us the information we need to parse the rest of the file. I use the term parse loosely, right? So we've already said that all of our different sections only exist if their data count is greater than 0. So we've got our submeshes, our bone count, our node count, our animation count. These sections that go along with that will only exist if their count is greater than 0. And then, of course, we have this animation channels, which is goes hand in hand with the animations here. And so, of course, this particular section of the file will only exist if the animation section exists, and the total channel count is 0. We will be baking in other sort of checks into this to make sure that some of the things that we're doing are valid. For example, it doesn't make sense to have an animation with no animation channels. So we'll be building in a little bit of logic to kind of catch some of those things and at least warn about them, before doing anything further. All right. So like I said, we're going to start with the header on this. So I'm just going to bat this out of the way for now. And I had actually a couple things here that I was kind of loosely thinking about putting together, whatnot. I'm going to delete all of these structures for now. And I'm going to kind of refer to things a little bit different. I'm going to rename some things. So instead of animated mesh header, we are now going to just say K3D header, right? And so everything inside of this is going to wind up being renamed to have K3D as its reference. And the K3D stuff will only be used within this particular serializer. And for now, what we're going to do is we're going to take all of the data that we read into these K3D structures, and we'll use that to build up, for now, this animated mesh asset, but eventually we'll also do we'll convert the static mesh assets to use that as well. And we'll probably combine those two as well into just a single K-asset mesh with, a few flags to indicate whether or not it's animated. All right, so I guess what we should probably do, I guess I'll drag this down here, but I'll sort of bat it off to the side for now. Let's just do that. So the first thing that we need, and I'm not going to actually use this binary asset header because it doesn't exactly fit 100% with what we're looking for. There are some things in here. Maybe I can grab these things, but I'm not going to use that, right? We're gonna standardize some of this stuff, but all right. So we have the Kohi magic, so that is going to be a U32, and then we have the type. We're going to call that the asset type, and then the version, which is going to be the asset type version, and then we have a couple of other things. So we don't have this data block size. We have the exporter version, which actually, thinking about that, we are actually missing something for that. We do have exporter version, but we don't have any sort of exporter identifier of any sort, right? And so what we might want to do is we could either include some exporter information, like as a string in our string table, which is all the way down here at the bottom. Or we could just include, some sort of number or something along those lines for that. I think what we might do is we'll go to this and add into our documentation here. Let's see. So let's put in here before exporter version. Let's add exporter type. And it's going to be largely meaningless for now, right? But we'll put in a U32 for this. So we're going to say use to track the type of exporter used, right? And like I said, that'll be largely meaningless. We'll expand on it later, but at least it'll give us another identifier that we can use. So we have a U8 exporter version, and then the exporter type comes before that. So U32 exporter type. All right. Okay. So the next thing we have is extents and center, which is what we already have there on the left. And then after that, we have the inverse global transform. So that needs to move here. All right. And then we have the mesh type. So this is actually going to be kind of important. That's going to tell us how to actually load the data. So we're going to say mesh type, and we will convert that to an enumeration afterwards. So that's U8. And then we have the submesh count, then the bone count, then the node count, then the animation count. Okay. So this string count doesn't exist anymore. That will be moved down here and become a U32. And what do we call that? I think we said string table offset. So we're going to say string table offset. And this is going to be the offset in memory of the strings table in the file. Sure. Or the offset, I guess we should say the offset of the string tables. Strings table in the file. Yeah, that makes sense. Okay. So that should pretty much be a one-to-one representation. So there's a couple things we need here. So exporter type, I'm largely just going to ignore for now, but at least we have it. The mesh type is something that we need to define, right? So we're going to say, I guess we'll do a type def, and we'll do K3D mesh type. K3D mesh type, right? And we'll have K3D mesh type. And I'd actually spelled out in the spec which one was which. So 0 is vertex 3D. So I guess I'll just say static equals 0. And we're going to say that that maps to vertex 3D. And then we'll have also a K3D mesh type skinned is equal to 1. And that maps to skinned vertex 3D. Right. Let's see. I forgot enum here. Okay. So that's that. I believe I have that correct. Skinned vertex 3D. Yes. Okay. So we can use that. Essentially, just cast this to K3D mesh type. Determines vertex format. Oops. All right. So that's pretty much the header. Fairly straightforward stuff. Eyeless42, good to see you. RCW with a stream streak of 5. Appreciate that. How are you doing, RCW? Good to see you. Let's catch up on the YouTube side. Let's see. You scare me as your beard grows, your power level grows even more, even more maximum. That's funny. How have you been? Been a while. Noticed your previous video. Was actually about to watch it for education. Well, I appreciate that. I'm doing well. How have you been? Let's see. Binary serialization is often the least preferred option over text. I noticed in our field. Why binary over text? I figured you modeled your data strictly. Speed, my friend, and also compression, right? Because if I did this in a text format, I'd have to parse all that stuff. So, when we're reading and writing these files, binary is going to be the absolute fastest way to make that happen. Sure, it's not human readable, but that's okay. It's in a lot of cases we can pick up the data straight out of the file and load it into memory, as we're about to do with this header. And we don't have to do any sort of text parsing whatsoever to get that. How do you get this good at CPP? This is C, but not CPP, but practice, just like anything else, any language. You've been doing it for a bit less than a year and still nowhere near good. I mean, it's relative, right? It depends on how much you actually write it and do it. The only way to get good with it is to continuously do it and continuously practice and write more than trivial applications with it, right? Make some relatively complicated stuff with it, and that'll teach you a lot of lessons very quickly. But yeah, what you're looking at here is C, not C++. But, the concept still is the same. We can just generate it. What do you mean, that guy? Are you baking the data into the executable or its own binary file? It's going to be its own binary file, although theoretically, if we really wanted to, we could build it. We could bake it into, the binary, because it's just binary data. So in theory, we could technically do that. I'm not going to do that, but what we're going to wind up with at some point is we're going to, and when we wrote the packaging system, we had this in mind, is when we go to release this, we're going to read through our asset manifest. We're going to take all those assets, and we're going to package them into a massive binary blob that then has a lookup table at the beginning of that that we'll use to read into that file and pick different assets from different offsets within that huge file. That's the long-term plan. We don't have to write that bit until we're pretty far down the road. So I'm kicking that can down the street. Reading directly off disk for now is fine, because the only difference between those two things is where we get the bytes from, right? Whether the bytes come from a massive amount of memory that's been read into from a file, or whether we're just picking it up from individual files. It doesn't matter at that point. Generate K3D, I was commenting on it being non-human readable. Yeah, if you wanted to, theoretically, you could spit out a secondary sort of format to this that is human readable at the same time you're serializing it, just, for debugging purposes. I don't think I'm going to do that, but you could do that theoretically. We're going to have lots of checks and balances in place, and we'll probably even add more to the spec as we go, to make sure that we're actually, reading this data in as we expect. But yeah. Let's see. Do you ever get tired of the same returning questions, or do you lie in bed at night thinking of new ways to answer them? No and no. So, I never mind the questions, because you've got to learn, right? And I definitely don't want to be one of those guys that gatekeep stuff, right? The whole purpose of doing this is to not gatekeep, right? And so, no, the questions are always welcome around here. That's how we operate. I welcome them. There are no dumb questions. There's just different levels of exposure and expertise, right? That's the way I look at that. I hope that makes sense. Okay, so I honestly feel like we should probably handle the deserialization first and then handle serialization. I guess it doesn't really matter. I just feel like when we're reading it out into this, we'll be able to determine, hey, do we have everything that we need to actually fill out this end structure here? So yeah, I think what I'm going to do for now is I'm actually going to come here and I'm going to move this to the top. And I know serialize is going to be busted for a while, and that's fine. I'm not worried about that. So I guess we should probably do cannot deserialize without a non-zero size block of memory and a we're just going to say an asset to write to, right? So we just need to make sure that these pointers are valid. That doesn't change. Let's see. So I'm trying to remember why we did this. Seems a bit unnecessary. Because then we'd have... Okay. You know what? I'm actually tempted to remove most of this logic and just write it from scratch. I think that's what we're going to do. Let's get rid of... Let's get rid of all that stuff. We're going to write this from scratch, I think. In fact, most of this is going to wind up being the same, but what we want is we want K3D header. And essentially what we're going to do here is we're going to take the block memory that we have. We are going to just cold cast that to the header, right? So that's essentially the way that we're going to read the first bits of memory out of this. We're going to cast the whole thing to that. And then we're also going to keep a, you know what, let me change this to in block. And let's just get rid of that. We're also going to keep a U64 offset equals 0, right? So the first time we can essentially get away with just casting or cold casting in block to the header type, right? And that's essentially going to be just checking this, right? So we check the very first thing is we check that magic number that's here, this guy up here, to make sure that that is valid, right? So we'll check that first. That's our first sort of bit of logic there. And then the next thing is going to be the asset type. So we don't necessarily have to process all of these things in order, but we can do some, you know, some relative sanity checking here. So I guess one thing that we can do is we can do a, what did I call that again? It was K3D mesh type, right? So we can get the mesh type, K3D mesh type. And that's going to be equal to K3D mesh type. And that's going to be the header. And then mesh type, right? So we can cold cast that. We can also do a assertion on that. So we can say header mesh type, oops, is less than, and actually we should go here and add one more down here. And we're going to do K3D mesh type max. And we're not going to set a value on that. We're going to let that auto expand as we add more of these, right? Whoops. And so what this will be is B2, right? And so we can come back here and say we want to assert that the mesh type is less than K3D mesh type max. And so if it isn't, it's going to bleat at us about that. In fact, that should probably not even be just a debug assert. That should probably just be an assertion in general. So we want to make sure that the ensure the mesh type is valid, and cast it to the enum, right? So that's all we're essentially doing there. And then let's see. The asset type we should probably confirm is going to be this, right? Which we don't actually have in here. So we're actually going to have to go to... We're going to have to go to... Let's see. Do we actually have... We do have it up here. Okay, so we already have... We have an asset type in here for static mesh, and we have one for animated mesh. I don't want to remove those yet, because we are still very much... we are very much, you know, kind of still building this out. So we're going to just put that here at slot 15 for now. And this should be K asset type. I need to fix the spec on that. Where was that? That was down here. Yeah. This should just be that. Okay. So the next thing that we want to do here is we also need to do a K assert. And the header asset type must be K asset type K3D, right? We need to make sure that that asset type is correct. So I guess the version doesn't really matter for now. It's going to matter more in the future when we actually have version differences. But for now, everything's going to be version 1. Extents and center, I don't think we really need to sanity check that yet. Inverse global transform, I don't think we need to do anything there yet. Mesh type we've already taken care of. So submesh count, technically speaking, we can have one of these that has no submeshes. So a value of 0 here is valid. Same is true for any of these other things, right? Because we can have, we can technically have one of these that has none of these individual things. Or maybe it only has nodes that are named that we use. And maybe those nodes are animated as opposed to submeshes or something, right? So I think, you know, all of these can either be 0 or non-zero. And then the string table offsets, we won't know. Well, I guess the string table offset is going to tell us where in the file we can actually stand up our, or get the memory for our binary string table. So we do need to get that. So let's do U64 string table offset equals header string table offset, right? And what we can do is we'll do a void pointer and we'll say string table memory equals, and then we'll just do a cast here of the in block, and we'll do that plus string table offset, right? And then we'll take this entire thing and we'll cast that to a void pointer. That'll give us that block of memory, right? So we then can actually take that. You know what? Let's just actually do header, right? We'll take that and we'll do string, or I think it was binary string table from block, right? And then we'll do string table memory, right? And then this will be binary string table equals that, right? So this is extract the string table from the file. All right. So what that's going to basically give us is all of our names for stuff. And it's going to give it to us in a queryable format so that we can actually extract those things as we proceed through the file. Okay, everything else from this header we can use as is. So I think the way that makes the most sense for this is to proceed through the sections one by one. So the header is obviously technically section 0. So the next thing that we should do is we should take a look at the submeshes section. But before we do that, there's something that we need to consider is this only will exist if the submesh count is greater than 0. So to get that, we're actually going to have to read in this guard value here. So before we can do that, we need to take this offset and increment it. So we'll say offset plus equals size of, and we're going to do K3D header, right? And then essentially what we'll do is we'll take, we can actually reuse this same logic. And we can say if header submesh count, then we want to read the submesh section here. But what we're going to do is we're going to get, like I said, the guard value first. So instead of this, what we'll do is we will cast this to a, I think it was a U32. Yeah, we're going to cast this to a U32. And we're going to call this guard, right? I'm going to say guard is equal to that plus offset, right? And then we'll be able to look at guard based on what section comes next and make sure that they actually match. So in this case, what we're going to do is we're going to do, we'll increment the offset again by size of U32. So we'll move the buffer forward by that much, essentially. And then from here, we can say, well, if we have the submesh count is greater than 0, then the next thing that we want to do is the guard should indicate the correct section, right? And that section should indicate this, right? So what I'm actually going to do is we actually have a few different sections here, right? A few of these different guards, right? So we have submeshes, bones, nodes, and animations, and animation channels, which all have their own individual sort of guards in them. And then we also have strings, right? Which is technically before this string table memory, right? So I think I'm going to put those in an enumeration as well. And we're going to do K3D guard. Or I guess, yeah, guard. K3D guard. And I'm just going to do this one. Oh, I grabbed I grabbed the last one first. Okay. So this is going to be K3D guard strings, right? And we're just going to set it to that. Yeah, and these are in order. Okay, so we have let's just paste that a few times. So the header technically doesn't have a guard. So we're actually just going to switch that to 0. The next one is going to be, let's see, what was it? Submeshes. And then the next one after that was going to be, I need to make sure I get the order right here. Bones, then nodes. Bones and nodes. And then I think it should be animations and animation channels, right? So animations, and we're just going to say anim channels, right? Oh, I overwrote the last one. This should be anim channels. All right. So obviously that means that this one is going to be 1. Did I? Yeah, there we go. That one's going to be 1. This one's going to be 2. This one's going to be 3. This one's going to be 4. This one's going to be 5. And the last one's going to be 6. Right? So now that it gives me a very easy way within here to make sure that the guard is correct. So we can do k assert, and we're going to say guard, and we're going to dereference that, equals, and we'll do K3D guard, and this should be submeshes. And if it's not that, then we have a problem, right? Okay. So the next thing that we need to look at is actually extracting this data. And so for the most part, this is going to be the number of meshes, right? So each one of these are essentially a array of data that is the size of, or has the number of elements of submesh count. So essentially the structure will be just arrays all the way down here for all these things. And then we have a vertex data buffer and an index data buffer. And so let's see, this is going to wind up being essentially an array of F32s that's going to hold all of the vertex data in it. And that's either going to be for the skinned vertex size or the standard vertex size. And that's going to be how large that actual buffer is. So we can extract that memory. And then the index data buffer will contain the indices, which will always just be U32s. Boons, yeah, exactly. Good evening, Diamond. Good to see you. Does K3D also have the VFX stuff in it that goes along with the animations? When you say VFX stuff, what things are you talking about specifically? So I guess, you know what, before we do that, I kind of want to map out these other sections, right? Let's see. So we'll do read the section, and then we're actually, nah, I'll do them one at a time. It's fine. Increment the offset. So the next thing we're going to need is a structure that holds all of these things, right? So we're going to have to come back up here, and we're going to do, I guess we'll do K3D submeshes. So we'll type def struct K3D submeshes. K3D submeshes. And what this is going to have is everything after the guard, right? So we're going to have all of these name IDs, which is basically just going to be a U16 array. A lot of this is going to be either U16 or U32 arrays, right? So let's do U16, and this is going to be called name IDs. And then what is it? I think it's material name IDs next. Yeah, material name IDs, and then vertex counts and vertex offsets. So those are going to be U32s. So vertex counts, U32 vertex offsets. And then we have the same thing for indices. I know that. So we'll just do index counts and index offsets. And then centers and extents. So the data type for those is vector3 and extents 3D. So we have vector3 extents and centers rather. And then extents 3D array extents. Right? And then we have the vertex data buffer, which is essentially just going to be a F32 array. So F32 vertex, what do we call that? Vertex data buffer. And then U32 index data buffer. All right. And so that is essentially what that structure looks like. The only problem with this is it's not, unlike this section up here, it's not just like flat mapping a section of memory to a structure, right? So essentially the way that the memory is going to be laid out is it's going to be this guard, and then it's going to be this entire array of things, and then this entire array of things, and then this entire array of things, and so on and so forth. So it's not like I can do before where I just kind of cold cast a section of the memory to this. I actually have to build out this structure based off of the contiguous memory that's in here. So we have, if we do K3D submeshes, and we'll say submeshes here, and we're just going to zero that out for right now. And so what we're going to do is we're going to read in each one of these arrays. I guess not read in. We're going to, how should I put this? We're going to essentially have pointers into the huge block of memory. So we're not going to allocate anything new here. We're essentially just setting up pointers into this entire thing. So name IDs is essentially going to be starting at offset, which already would have been incremented here. So actually, if we just take this and do a paste here, what we can do is we could say submeshes and then name IDs, and we're going to cast this to a U16 array, right? And that's essentially the way that that's going to go. So our name IDs is just that. Now we can actually do offsets plus equals, and we'll do a header submesh count times size of U16. Right, so we move essentially our offset pointer that much further into the huge block of memory. So within that, we have the name IDs, and then from there, we essentially are going to repeat the same type of thing for material name IDs, which again is just using that offset. And then again, we essentially just do this, right? Same operation there. So that is essentially the way that we're going to step through this section of the file, right? It's just gonna sort of be built out that way. So we have our vertex counts next. So that's going to be essentially the same operation, right? Except it's U32 there as well, right? So we have vertex counts, vertex offsets, which again is always the same. And then we have index counts and index offsets. All right. And so you can see, as far as setting this structure up, it's literally just pointing to different places within that huge block of memory. We're not having to do any parsing here. And in fact, we could probably even skip this step and just, do the math in line, but this just makes it a little bit easier for us to understand what's happening in the code. So the only other thing that we have to do now is, let's see, there's centers and extents is the next two things. So we'll do centers, right? And that is actually going to be size of vector 3. Right? So we've got that. That should be centers, plural. And then we have down here extents, and this is going to be extents 3D in both of those places, right? So we've already incremented the offsets for all of these things, right? The last couple things we need to get are the vertex data buffer and the index data buffer. And this isn't going to be very difficult to get either. So again, I'm just going to kind of copy this, and we're going to go, we're going to do extents. Instead of extents, it's going to be vertex data buffer is going to be the next thing in line, right? And so that is just going to be a F32 array. We're going to cold cast that. And then here in the offsets is where things are going to get a little bit tricky. So it's going to be the F32, right? But instead of, actually, I think we can just do trying to think if, can you do a ternary inside of a size of? I don't think I've ever tried that before. Something tells me no. Let's just do it this way. So, you know what? Actually, I don't want to do it this way. We're going to do U64 vert size equals. And we're going to do size of vertex 3D. And then here, we're going to do, I guess we can default to that, and then we'll do switch here, and we'll do mesh type. And we'll fill that in. And we'll essentially do essentially do that, right? And then we'll also say down here for skinned, that's going to be skinned vertex 3D. Put a break here, right? And then we'll do vert size here. Right? So we're essentially saying, what is the type of geometry that we're dealing with? Is it, your standard vertex 3D that's static, or does it include skin data? If it includes skin data, obviously we'll need to treat that a little bit differently because that is a little bit larger of a structure than this guy, right? So we have that, and then we simply just move the offset beyond that. And then the last thing that we'll need to do is we'll need to do this one more time for index data buffer, right? That is going to be a U32. And then the U32, or what we're going to do here is we're going to move, let me think about this for a second. This isn't completely correct up here either, because we need to actually know total vertex count, right? Per mesh. So we may actually have to store a little bit of extra data. Oh wait, we actually have that, don't we? We do have that. We have vertex counts here and we have index counts here. So we actually have to do one more bit of logic. Because what we actually need is, I guess we'll do a U64 total vert count equals 0. And we'll do a simple loop, so we'll say U32I equals 0, I is less than submeshes, vertex counts. Wait, no, I do want header. Sorry. Header, submesh count, plus I, right? And we'll do total vert count plus equals submeshes dot vertex counts sub I, right? And that'll give us the total vertex count. We can also get the total index count at the same time. And so that's going to be basically the same idea, except we'll be using index counts instead, right? So I guess we can take this and put it up here. Just do that ahead of time, right? And then down here, instead of the submesh counts, we're going to say the vert size times the total vert count. And then here, this is going to be the total index count times size of U32, because that is how big a index is. And at that point, we will have moved the offset to where it needs to be further down here. So at this point, we will have extracted all of this data out of this section. All right, let me catch up on comments because I know I was kind of in the zone there for a minute. So let me scroll back here. Like at specific points in animation, you need particles to go off. So that is something we are going to have to add. I haven't completely decided what I want to call that yet, but it's probably going to be like triggers or something like that. But yeah, we are going to add some of that stuff. I'm starting off with a very simple kind of format first. And that was one of the reasons why I called this K3D instead of like I mean, I guess this says model format, but it's not necessarily just going to be limited to models. Because the idea is that theoretically you could have nodes in here that do different things that you could then use as like a mount point for another mesh or something like that. And I think having triggers in there would probably also be something that we should probably build in support for. I might do that for like a version 2. Have a tool that imports the mesh and animation. I can attach particles to specific points and export it into my game's custom format. Yeah, okay, I think we're talking about the same thing there. Okay. Isn't it total vertices? Yes. Times vert size. Yep. Not submesh, you had the counts. Yeah, exactly. Yep. I caught myself on that one, thankfully. Thank you for the stretch redeem. I appreciate that. Might be worth storing the total counts in the struct for when you want to loop over the vertices indices in the future, maybe. I thought about that. I mean, I very easily could put it in here, right? But I feel like this loop is going to be fast enough, it doesn't really matter all that much. But if I need it in the future, I will definitely do that. Instead of doing the addition again. Yeah, I mean, I don't know. We'll see. We'll see how it works out. I may wind up adding that in there. It wouldn't be too big of a deal to add it in there. I don't think I'm going to need it at the moment because it's quick enough to do this. So, will it work on Android? Not at the moment, but eventually, yes. I am going to be writing a mobile renderer backend for this at some point as well. Test. Yeah, I did see the message. Sometimes it just takes me a minute to actually get to it. Ternary inside size of is triple star pointer level programming. Yeah, I don't know if you can actually do that. Because what I was thinking of doing was basically just wrapping this in here. I've never actually tried that. Like, can you do size of, and then say mesh type equals K3D mesh typed skinned, for example, and then say skinned vertex 3D or otherwise vertex 3D. I don't think you can do that, can you? No, I didn't think so. Yeah, it doesn't like that at all. That'd be kind of cool if you could do that, right? Because I've definitely run into situations where I wanted to do that before, but Godbolt time, yeah, I don't think it just doesn't seem right to me. Doesn't necessarily have to be in the spec, could just be in the struct, but yeah, later. Yep, exactly. Time to rewrite the compiler to make it work. If Duff's device is legal C, so is this. Yeah, I was reading about that the other day. It's very funny. I mean, time to invent the Kohi language, right? What would I call it? K minus minus? Let's see. When you code, you lose yourself. You lose yourself to the zeros and ones in the machine's magic black box. Yeah, exactly. By the way, I'll have to go start writing a toy message pack. Oh, I gotcha. Okay. If size of array 0 works, ternary might work if the condition is compile time constant. But how could it be compile time constant? In this scenario, that wouldn't be possible, unfortunately. But yeah, I mean, it's not a huge thing. It was just something I was thinking in passing. Okay, so from that, let me think about this. So I feel like we should probably actually have, I feel like we should have this out here regardless, right? And so submeshes just isn't going to have any data filled out, but we still need to be able to access it from other sections, I believe. So I'm going to hoist this up here. And let's see if I missed anything as far as... No, I don't think so. All right. So yeah, I think the first thing I'm going to do is I'm going to read all the stuff from each section. I wonder if I should just do the processing all now too. No, I feel like I'm going to read through these sections first, and then I'll do all the processing at the end. Because I think there's going to be some crossover that I'm going to have to do. All right, so bones are going to be pretty simple. Again, we are going to need to do one more guard check. So let's see, we can essentially just do this, actually. I'm going to copy that whole bit there. And we're going to go down here, and we're going to add another section. And we'll just update guard. And then K3D submeshes will actually need to come up with a new structure here. So this is just going to be name IDs and offset matrices. So just an array of U16 and mat4s. So we'll call this typedef struct K3D bones. K3D bones. And we have a U16 array that was just name IDs. And what was the other one? mat4 of offset matrices. So mat4 offset matrices. And that's actually all there is to that one. So this is going to be K3D bones. Right? And this is going to be if bone count is greater than 0. And then we want to make sure that the guard is the correct one. So we can actually go up here, and this is actually going to be pretty much the same code. So I'm actually just going to copy these two things. And all we actually have to do, we need bones to be updated here. So this is going to be bone count in both of these places. And then here we want offset matrices, and this is going to be mat4 in those two places, right? So we read all that data in, and then we increment the offset in both cases. That's all there is to reading the bones if we have them. Pretty straightforward stuff as far as that goes. Way simpler than, I think that's probably going to be the easiest section, actually. This one isn't far behind it, though. So nodes just has 3 properties. So we'll do typedef struct K3D nodes. We'll do K3D nodes. And let's see, we have a name IDs again. So U16 name IDs. And then let's see, another one, which is going to be U16 parent indices. So U16 parent indices. And then local transforms is going to be another mat4. All right. So literally, we're just going to take this section and copy pasta it, except this is going to be nodes. This is going to be nodes. This is going to be node counts. It's also going to be node count here and here. And then this is going to be nodes. We also need to update the guard. Okay. So this is going to be nodes. And this is going to be nodes. Except, what was the one called? Local transforms in this case. Right? Okay, so we have parent indices we just need in the middle. So we've got parent indices there, and that's pretty much it. So that's that section. Apotham, good to see you. How's it going? ++ K -, that's funny. Why don't we just do ++ -, as the name of the language? Or just +-. Or maybe we'll just call the language 0. That's actually not bad if it doesn't already exist. Diamond, I could do that, yes. Yeah, it's just visually different. Yeah. Yeah, that would work as well. Feels like those two lines could be a define for some nice cursed C. Right? C flat. Ooh, C flat's actually kind of funny. Because of C sharp. I see what you did there. I like that. You're talking about these two lines here? CB, which would be C flat. Yeah. Yeah, I see what you mean. Okay. Oh, there's a... I just thought of something, though. This guard situation is not going to be correct, right? So we read the header, then we read this guard, right? So we have header, then we have a guard. It could be this guard, it could be this one, whatever. But we only check to see what that guard is when we are successful in our check here. So if this were to fail, if we had no submeshes here, we would just say, okay, we're just going to go down here and read another guard. I feel like this should actually be as part of this, right? So this should be read the next guard. And the reason for that is because if this check fails, we wouldn't be in submeshes. The next thing that we would check for would be bones. Right? But we wouldn't want to reread the guard because the guard that we read at that point, if this section didn't exist, would be bones, if this exists. So all of these guard checks, technically, shouldn't be between the sections. They should be at the end of the last section that was read in. So if we have this section, then that means, cool, we read that section, and then we should be reading the next guard. That's one of the reasons I was considering moving these guards out. But the guards actually only exist if the section exists. Yeah, I think that should work. all the pointer offset and then increment the offset. Yeah, it's repetitive and error prone. Yeah, I agree. Yeah, I don't really like it. I mean, I'm copy pastaing it everywhere, right? But like, that's kind of poopy. I don't really like it. I could just define it, I guess, make a macro out of it. Or maybe, instead of being a bananas, technically what I should do is that. That way I don't have to dereference it everywhere. So I guess I'm just gonna make it a function. I could do it as a define, but like, or as a macro, but like I think it makes more sense as a function. So let's do static u32 check guard. Or no, I guess we'll just do read guard. Right, so we have void in block. That needs to actually be const. And then we have the offset, which is going to be a U32. Actually, did I say U32 or U64 for the guard, or for the offset? U64. Since we're modifying it, though, it needs to be a pointer to that. So we will have to dereference that, but that's not the end of the world. And then we can return guard. I think I've got that right. Yeah. Okay, so this now becomes read guard, right? So we have in block, and then we take the address of offset. And now we can actually get rid of all that stuff. And then at the end of every section...
I'm not quite sure how to help you with that.
Oh, you stupid thing. I hate when Alexa hears something that it shouldn't. All right, so we have that. Yeah, that makes sense. Okay. So we have that, and then all I need to do is get rid of all these dereferences, and that is a lot better. I'm all right with that. Let's see. C optimizer assumes no alias when the pointer types are different, right? Random question. C optimizer assumes no alias when the pointer types are different. As far as I know, yeah. I don't see how it could assume otherwise. Yeah. Because how would it know? Like if you have a void pointer versus a U16 pointer, for example, like how is it to know that that's not? Yeah, I guess it wouldn't know. I would assume it would have to assume that, but yeah, I don't know. Good question. Thoughts on Graphene OS working to make a phone? I'm probably the wrong person to ask about that because I'm not all that familiar with phone architecture, to be completely honest, or phone OSs outside of the basic workings of graphics programming and the sort of small isolated space that is within that space. So I don't feel like I'm qualified to answer that, unfortunately. Let's see. The opening of your videos is still inside of your castle. How old is that now? 18 months. Any idea when we might see a cool updated new renderer? That's a good question. Yeah, you're right. You're talking about this screen. Yeah, I don't know. Good question. I think eventually what I'm going to do is once we actually have some gameplay coming together that looks halfway decent, I'll be replacing a lot of those graphics, probably on the channel too. But I don't really want to do it until then, because it doesn't really make a whole lot of sense to do it before then. I guess I could take some updated screenshots of, showing off some of the new lighting stuff in the test bed once I convert that over to work with all this stuff. But I don't know when that's going to be. It is more at first, but less at last. Barble, I'm not sure what you're referring to, unless that was... Yeah, that was like 10 minutes ago, I guess. So, can you be more specific? I'm not sure what you might have been referring to when you mentioned that. Gotta love Sponza. Yeah, exactly. It's still in the test bed, but at some point I'm probably going to remove it, and we'll have our own assets in there, but I just haven't had time to make assets, to be completely honest. All right. All right, so where did I leave off? So we have bones, nodes. That means animations next, I believe. 1 second. All right, so... animations is actually kind of the same thing. The only difference is we have a total channel count. So all of our animations have a certain number of channels in them. And the way that we are sort of putting the two of those together is the animation channels section relies on the animations section to exist, which makes sense. Because animation channels are a subset of animations. So there's a one animation to many channels, potentially. And so what this is this is saying for all animations that we have, this is the total count of animations or channels across all those animations. And that count indicates the size of the arrays in this section. And so when we're deserializing that, that's how we know how to actually obtain the offsets in here. And then as far as relating them back, right? So relating animation channels to animations, essentially the way that works is we have the channel animation IDs here. Oof, you know what though? I guess we could say the order that they're read in is the order that they should appear. We could put like an animation or a channel ID to indicate like what index it should go into. But I feel as long as we write them in order in the file, we don't have to do that. That's the way I'm going to treat it for now. If it winds up being an issue, we'll resolve it. Okay, so we're going to need a new structure. This one is going to contain pretty much all counts. So this is going to be, let's see, names, durations, ticks per seconds, and channel counts. Okay, so I'm just going to cheat and copy this. Copy pasta. And we're going to say K3D animations. And name IDs can stay the same. And then we'll do channel counts. We'll call this one channel counts. I'll move this. Oops. We'll move this one down. And then this one is going to be a U32. And this is going to be, wait a minute, F32, not U32. I was going to say that seems wrong. Durations. And then ticks per second. Per seconds. And yes, I realize that sounds awkward, but it's ticks per second. It's an array of ticks per second, right? Per animation. And then we have our total channel count up here, which is, did I say that was going to be, wait, a U16. Okay. So U16 total channel counts. It's going to be there. All right. So I'm actually going to, again, just copy pasta this because the logic is pretty much the same. So this is going to be animations. This is going to be, instead of node counts, animation counts. Guard is going to be animations. And then here, instead of nodes, this is going to be animations for all of these, which I realized some of those are wrong. That's okay. We'll fix them in a second. So the first thing that we want to do is actually come down here and do animations, total channel counts, equals, and then we'll actually just take that. And what did I say total channel count is? It's a U16, I think I said. So we want to just dereference that guy. And then we move forward a single U16. All right. So we read the total channel count. We read the name IDs. Then we read the durations and ticks per seconds, right? So durations, this is going to be F32. Same here. And of course, this is not going to be node count. This is going to be animation count for all of these. So let's just fix that. Right. And then this is going to be, you know what? I'm actually just going to delete that one and copy pasta this one. So this is going to be ticks per seconds. And that's going to be the same thing. And then the last one is a U16 again. And that is going to be our channel counts. Right, so we're going to have channel counts. And that is a U16. All right. So that's going to do it for our animation section. And then since the animation channels section relies on animations, I probably ought to put it within this branch. I mean, it's going to miss some error conditions if not, but I think as long as we don't foobar our exporter, we'll be all right. So we read that guard. We're going to say now animation channels, right? And I'm actually going to come up here and do K3D. Wait a minute. We need a new structure for this, actually. So we need a bunch of arrays again, and one buffer of F32s. So let's go up here. And I'm actually just going to copy pasta this again real quick. And this is going to be animation channels. Let's see. Thank you for the follow, by the way. Appreciate that. Good morning to you as well. Let's see. If I'm going to make a game engine for 2.5D and 3D, not photorealistic, but have very good physics, what should I do so that I can use it to power all my games? I know C++ is very good, but no graphics programming, so I can use Relib. Or should I really use graphics programming or something? I love making engines, not games, though. If you like making engines, if that's really what you want to do, then probably learning graphics programming is going to be the way to go if you're wanting to do that. If that's what your goal is to make an engine. That being said, though, just making an engine without making a game is kind of pointless, right? Because you need to do what's called dog fooding, or eat your own dog food, which basically means that you need to use the tech that you are building to essentially test. You need to use the tech that you're building to build a product, and ideally take it to release as a way of testing that what you built is good and works. If your goal is to make a game, do the bare minimum you need to make your game. Yes, I would agree with that. When you make your second game, you can take parts of your first game and reuse it with improvements. Yeah. A solution, finding a problem. Yeah. I mean, like, I want to make a game, but it's a survival game. Yeah, so if your goal is to make a game, then, only make what you need to make. But also, if you're interested in graphics programming, explore that, but realize it is going to make it take longer to make your game. There's pros and cons to that too, right? If you make it all yourself, you have full control over everything, but that's both a pro and a con, right? Because if you have full control over everything, you also are the one that supports yourself doing all of it, right? So that means all the bugs and issues with it are on you to solve. And that's not necessarily a bad thing. Depending on where you're at, that can be, it could be a snare, or it can be a boon, depending on how you handle that. So, pros and cons to everything, right? If you're just wanting to make a game, though, I would say start off making a game with, something like Relib is a fantastic library. You can build something really solid with that. So I would say build your first game and then take whatever parts that you want to reuse into the next project, because you're going to learn a lot about making a game by making and completing and releasing a game, right? You're going to learn a lot about that entire process. So you're going to want to take all the lessons that you've learned and say, okay, these are the sections of code that really worked, and these are the ideas that I had that really worked. And those are what I can carry forward into the next project. But then these other things that I had over here that I tried didn't really work. So I'm going to try something different than those, and just only carry forward, the parts that worked. But yeah, I wouldn't start off making an engine unless you're setting out to sort of do that as, as your goal, right? Careful with scope creep, start small, that too. Yep, 100%. Don't add engine code that you have no use for. Yeah, only write what you need. Yep. Yeah, I would agree with all that. Yeah, Raylib is a fantastic library. I would say, if you're learning game programming and you're set out to make a game, use that. There's nothing wrong with that. For most things, it'll get you where you need to be. You could also use that to learn, how to build it. And then at some point, if you say, hey, I want to learn how to do the really low level stuff after that, then jump into graphics programming, right? Again, it depends on what your goals are, what you want to learn, what you want to do, how long you have to do all of it, how much time you have, plays a big role as well. So yeah, I hope that helps. But yeah, Raylib is It's pretty good. Don't focus too much on optimizing and modularizing things early. Yes. That leads to lots of refactoring, which we've done here on the channel as well. Because we've tried, we do a lot of trial and error on this channel here. And I do that on purpose just to show you guys how things can, early assumptions can kind of bite you, right? Because that's part of the problem. Part of the process of doing this is not only showing the cool things that work and all the shinies, right? But the bits of it that don't go so well and require rethought or rework, which is realistic when you're working on a large project. So, yeah. Anyway. So this one we don't actually... Oh, we do have name IDs. Okay, so channel name IDs. I don't know why I prefixed all of these with channel. Probably because I was thinking about putting them in here at first, but I probably ought to rename some of that. All right, so I'm going to go with animation IDs and name IDs. We don't need that. So this is going to be animation IDs. And then let's see, we have name IDs, then we have position counts. So these are just counts, right? Counts and offsets. Rotation, counts and offsets. And then scale, counts and offsets. So let's go, I think those are all U32s. So we'll see position counts. And then we'll do U32 position offsets. Didn't I think I just did pause before. Let's just do that. And then we have was it rotation or scale next? I forget. Rotation, then scale. Rotation. And then scale, right? And then finally we have F32. And I guess we'll just call this data buffer. Okay. And so this is going to be a buffer of F32s that stores all position, rotation, scale data for all animation channels. Boy, this one's going to kind of suck to calculate, but well, I guess not really. Nah, that's not going to be too bad, actually, now that you think about it. All right, so K3D animation channels. Let's go down here. So our animation channels here. Whoops. So we'll do, I guess we'll do, I'm just going to call this channels, I think. Equals, and actually this has to go up here. Need that up here. Right, we're going to unflatten all these structures after we actually have them all read from the file. After we read the guard, we need to assert that we're in the right section. All right, so this is going to be anim channels. Should be the next thing that we read in. And then, yeah, we're essentially going to have to do if animations total channel count exists, then we do this. Yeah, that makes more sense. Okay. So at this point, we just have to extract all the counts, right? So let's see. So we have the animation IDs, the name IDs, right? So this is going to be essentially just this twice. The first one is going to be animation IDs. Animation IDs, right? And this is going to be, instead of animations, this is going to be channels. So let's fix that real quick. And then instead of animation count, this is going to be animations. Total channel counts. And that'll be the same thing there. Okay, and both of those, I think I said were U16s. Yes, they are. Okay, so we've got that. And then all of the counts and the offsets are all U32s. Okay. So let's, I guess we'll just grab this one. So it's going to be channels, position counts, I think was first, counts then offsets, right? Yeah. So this is going to be U32. And then, whoops, we have this again. Animations, total channel counts. Right, so we read all of those, and then we have position offsets. That should be the same thing. So we have this we'll take a copy of. So we'll do rotation counts and rotation offsets. And then scale counts and scale offsets. Right? And then the only other thing that we have is the data buffer. So at this point, we'll just do data buffer, and that's a array of F32s. And then when we do the offset here, we're actually going to need to calculate based on the counts that we have above, right? So we're going to do, I guess we'll call this U64, and we're going to say data buffer size, and we're going to say 0. And then we'll do, for U32I, actually, can I use I? Yeah, I can. Okay. I equals 0, I is less than. And for this, we'll do animations, total channel count, plus I. And we're essentially going to do data buffer size plus equals, and we're going to say size of vec3 times, and we're going to do channels position counts sub I. Right? So we're going to do that for positions, rotations, which are quaternions. Right, so rot counts and scale counts, which are also vector 3s, right? And so that'll give us the entire data buffer size, right? Just by going through those. That's everything that's stored in the buffer. And so now we can actually literally just do data buffer size. Now, at this point, we have one more thing to do. We need to read the guard one more time. Okay. And at this point, we should be here in the file where we have the strings guard, right? That will always exist. So what we really need is just essentially this. We'll come down here. Let's see. This is after animations, right? So we'll do this here. And we'll do strings. And in this case, we're going to say the string section, which should always exist at this point in the file. So in theory, even if none of these other sections exist, then essentially what should happen is we should fail all of these if checks and cascade all the way down here, and this should still exist, right? This should still be here. And then once we've read that guard, another thing that we should be able to do is we should be able to then say kassert. And we want to say that offset equals header string table offset, because the very next thing that's going to be in the file is the string binary table that gets serialized, right? And I know we don't have that fully spelled out here in this file, but that's the very next thing and the last thing that exists in the file. And at that point, that is what gets processed there. Now, I don't think that we've actually done that in here yet. We've done it here. So I'm actually going to do... I'm going to take that away from here. And I want to process that all the way at the end. Right. All right. So at this point, we've read everything out of the file, as far as all of this data goes. Now what we have to do is we actually have to step through all the data that exists in these various sections, and we have to actually construct the various bits of things that we're going to need in this animated mesh. So that would be all these structures that we've seen before. So our animations, our bones, our nodes, our submeshes. And then within these things, you know, they'll have things like the vertex data, the indices, all those things. So this is where we probably need to think a little bit about a new asset type. Because we've come back to this K3D, right? And all we have right now is static mesh or animated meshes. Which we've already eliminated some duplicated code across those two, but now we're going to even eliminate some more. And we're going to combine those two asset types into one. So instead of having a K-asset animated mesh, we're just going to have a K-asset mesh that'll have all these types in it. And then we'll have to convert the systems that use these to handle those accordingly. Let's see. Let me catch up on chat. Best thing you can do for your programming career is ignore the Uncle Bob and his clean code dogma. Yeah. Tend to agree on that. Only problem with my game is there's more comments than code. Is that bad? I mean, if you're the only person looking at the code, then who cares, right? Comment on what you need to, so that if you come back to it in 6 months, you know what you're looking at. Here's my feeling on comments, right? And this is a little bit. This can be a little bit controversial, I guess you could say, amongst some crowds. comments are fine if they actually describe something useful, right? So what you don't want to have is something that's like this, where you have U32 I equals 0, I is less than 10 plus plus I, right? And then do something, right? If you have something that looks like this, and then you go, do this 10 times, right? And then you have another comment in here that says, call do something, right? These kind of comments are useless. Don't waste your time with those things. But if you have something that is actually useful, in terms of telling you like what your thought process was, on something that you're afraid that maybe just reading the code, you're like, oh, why did I do it that way? Those are fine. I also like to sometimes split up sections of my code with comments, right? Material asset name, like materials, the name string here is what we're processing with no null terminator, like important comments like that. Here's the index count. Here's the indices being processed. Here's the vertices being processed. And even this is probably a little bit more verbose than it needs to be. But I'm also writing an open source code base, right? So the idea is that this is also supposed to serve as sort of an educational reference. So I'm a little bit more free with writing comments in here than I normally would be if it was just something I was writing for myself. So it depends on your target audience, who's going to be looking at the code. If it's just you, just write down notes that are important to you. If you're doing something that's going to be consumed by others, then maybe be a little bit more liberal with your comments. But don't write useless comments, right? Try to write your code in such a way where it's kind of obvious what you're doing as much as possible. Like all of these, it's fairly kind of obvious what we're doing here. I guess that's kind of the point. Diamon's got some good examples in there for you. Always comment and variants too. Yeah, exactly. Just don't put useless comments in there that don't make any sense. Don't put comments in there that are about super obvious things that you could just read the code and say, okay, it's pretty obvious what this does. You don't need a comment for that. Okay. As Casey Muratori once said, comments are always out of date. Yes. So one place where that's especially true can be in documentation comments. Like, I guess the math library isn't necessarily, that. But like this, I pretty heavily commented, right? Because of, this is all public facing stuff, right? If you're writing an API that's going to be changing a lot, you're going to need to remember to go back and update your comments. There's a few places I know in the code base where these comments like this are out of date, So, something like a math library is not going to change that often. It's safe to kind of do this. But if you're working in stuff that's really hot and really changing all the time, don't bother with it until you're done and you're ready to release it, right? Okay. So we need to think about our new asset type. Assert and variants, don't comment them. An argument could be made for that, yeah. I'm a little bit more liberal with asserts now than I used to be. There's a lot of places in code where I do things like this and spit out an error message and return false, where I think it really ought to be an assert. There's going to be a lot of conversion in this code base to asserts at some point. But yeah. Constrain yourself while writing comments. Just write comments that are useful, right? If it's not a useful comment, don't bother. I guess that's how you sum it up in one sentence, right? Okay. The part that sucks about this is if I make this, well, all right, I think I'm just going to rip the Band-Aid off. I was going to say, because if I change these types, that's going to break everything that uses it. Oh well, I think. Or do I duplicate these types and mark these ones as... I don't really want to mark them as deprecated because this version isn't even released yet. Yeah, I think I'm just going to rename them, but I'm not going to use like the... I'm not going to use the LSP rename. I'm just going to do a rename in the file and break everything that uses it on purpose. That way I actually have to go through and examine everything that uses it to make sure it's using it correctly. Asset type name, mesh. Right, we're just going to call it... Actually, should we call it mesh? Because I don't even know that that's accurate anymore. That's actually... Because, like, submeshes are a thing, right? They're meshes within this thing that we're now calling K3D. We're kind of calling it a model format, but it's also an animation format. You know, it contains animation data, I should say, or skeletal data, like bones, all that other stuff too. I feel like mesh is not the right term to use for this anymore. I wonder if we should go with model instead. And we'll say that a model has meshes, has animation data, has bones, has nodes, etc. So maybe we'll change kind of the way that we reference this in code. Instead of saying meshes everywhere, even in the scene, instead of saying static mesh or animated mesh, maybe we just say model. And if the model has animations, then you can set animations to run on that model. Otherwise, you don't, right? I feel like that's a little bit cleaner. The only thing we'll have to do is find some sort of way to separate out how they're drawn. Clean mentioned, yeah. I mean, I don't necessarily want to be dirty, right? But I'm also not trying to play code janitor here. I guess we could go with model. Because I feel like that's a good separation of terms. Because otherwise we've kind of had this... We've kind of had this confusing, like, static mesh that can contain submeshes and animated mesh that can contain submeshes. Whereas if we have a model, that just kind of contains all of that stuff. Okay. So maybe the asset type shouldn't be K3D. Maybe the asset type should be model. Hell's Dragoon rating with a party of 21. What's happening, chaps? You guys got me. I'm actually running a little bit later tonight. But yeah, thank you so much for the raid. How's it going, guys? What'd you get up to on stream? I know I've raided you guys a bunch. I've gotten you guys a bunch right before you shut down for the night, so... If you guys aren't following Els Dragoon, definitely go do it. They're a tag team of two chaps writing a game for the NES and 6502 assembly from scratch. So definitely go check them out. If you're not following them, I would say it's an automatic follow. They're doing some really cool stuff. Their game is looking really good. I haven't had a chance to check it out in like the last week or two. But last I saw it, it's, every time I'm able to tune in there, it just looks better and better. Yeah. Oh, how the tables have turned. Yep. Got them. Yep. Exactly. Yeah. No, I appreciate the raid, guys. Doing great. Defeated an evil, but defeated an evil. Okay. But made strides towards, migrating off Adobe. Oh, that's always a good thing. Yeah. Evil bug. Okay. That makes sense. I was like, an evil what? Yeah. All right, cool. That makes sense. Yeah. So, the stuff that those guys are doing over there, way beyond what we're doing here. Like I said, they're coding in assembly over there. So there's definitely some real Giga Chad stuff going on over there. Arvis, I don't know. Automod literally blocked the word but. I'm not sure, Arvis, why that happens, but not just assembly, but 6502. Yeah, true. I did mention that initially, but yes. In fact, they've actually motivated me to want to try that at some point. So maybe whenever this project is done, maybe we'll do that. Els Dragoon, the Automod got you for that one too. They got you again. Politically correct term booty, and it didn't like that either, apparently. I don't know if Vulcan scares the crap out of me. It's not that bad. Writing something in raw assembly scares the crap out of me, so there it is. Automod needs to calm down, yeah. Automod is, it's on something tonight, apparently. Too risque, yeah. Haven't done assembly for years, but 6502 was always a challenge. Yeah, it's definitely one of those things I want to try, like writing something from scratch. I've like edited code and I've written small things, but never like an entire game in it. Haven't got past STL for graphics in C. Yeah, I mean that's not a bad start, but yeah, if you're looking to do it, I would say start with OpenGL first, so you get the basics down in terms of understanding all the concepts, and then once you get familiar with that, where you've written a couple of renderers, then I say jump from that to Vulkan or Direct3D 12 or even Metal as quick as you can. Thank you guys for the follows, by the way. Really appreciate that. Let's see. I was spoiled by the Z80. Yeah, I never had one of those.
You dingus.
I'd like to do 6502, but I know I need a couple months to know life it. Yeah, that's the thing. Like, I would have to lock myself away in a room for like a few weeks or something. Isn't Metal for Mac? Yes. Metal is Mac OS and iOS. It's their equivalent of Vulkan, if you will. My understanding of it, and I haven't worked with it extensively yet, I am going to be porting the Vulkan layer on this to Metal at some point. In fact, that's probably the next platform I'm going to do. Because right now I'm sort of using a translation layer to go from Vulkan to Metal. I probably am going to be doing Metal next. But from my understanding, that is a very nice API to work with. One of the best, from my understanding. It's a graphics API, yeah. So it's essentially the equivalent of Vulkan for macOS / iOS. So it's like the same as Direct3D, for example, but for macOS. So it's just their equivalent. The only crappy part is like I think there's parts of it like the Mac OS layer. I know you have to do some of it in Objective-C, which is not my favorite language. This is all if-deffed out right now because I'm on Linux, but I have done it. I'm not really a fan of that, but adverts. Okay. Yeah, it looks like there's a minute left on those. Gotta go figure out why my dog is freaking out, but I'll lurk and see you later if you're still going. All right. I appreciate it. Thanks again for the raid. Very much appreciated. You got me. How does it compare to OpenGL? So all of the new graphics APIs are much more complicated than OpenGL. So OpenGL is basically like a massive state machine that's maintained at the driver level. So it maintains a lot of state for you in terms of what's bound and what's currently being used, and how data is uploaded to the GPU. It kind of maintains a lot of that for you and abstracts a lot of that for you, which you'd think would be a good thing, but it also takes away a lot of control from you. It's also not very good with multi-threading, and doesn't have things like, modern things like ray tracing, hardware ray tracing. And so, OpenGL has been around for 30 years or so, but it's deprecated at this point. It's not receiving any updates, never will. It's essentially been superseded by Vulkan. So, the difference between OpenGL and these other more modern APIs, which would be Vulkan, Direct3D 12 specifically, or Metal, is that they are all much more verbose and give you much more control. So they get rid of that sort of internal state machine that OpenGL had, and they foist all of that responsibility, including things like managing your memory barriers and synchronizing read writes and all of that kind of stuff. They foist all the responsibility of that onto the application. So you are in complete control of that, but it also, with control comes the ease of shooting yourself in the foot. And let's just say I'm missing a lot of toes, but that's essentially the biggest difference, right? But I love GL state. It keeps me company. Yeah, I mean, it's great for writing simple stuff, but if you're writing a renderer using, and you're wanting to use modern techniques, it's not going to really do it for you as well anymore. There's just no way to eke out the performance of these modern graphics APIs because, all of these modern APIs are much better with multi-threading, for example, whereas OpenGL was terrible at it. So, yeah, I mean, there's lots of other reasons besides that, but you can literally control how things are managed. How and when things are executed or uploaded or read from or written to. You control all of that stuff. So, yeah. Anyway, that's pretty much my my soapbox as far as Vulkan goes, or really graphics APIs in general. So I should probably mention what the heck we're doing here. So what we're doing here, for those of you who are new, is we are writing a game engine from scratch. And we are using C as the language to do that, and we are targeting Vulkan as our initial rendering backend. And I say initial rendering backend because we do have support for Direct3D and Metal planned for the future, as I mentioned already. This is cross-platform, so it does currently run on Windows, Linux, and Mac OS desktop environments. So Vulkan runs natively on Windows and Linux, and then on Mac OS we use something called Molten VK, which is a translation layer to Metal for now until I write the Metal layer. So the project itself is free and open source. So it's available on GitHub. In fact, I'm going to drop a link in chat to this main website here that contains sort of all of the details of the project. Just a couple things about the project itself. So the engine itself will always be free and open source. So it's Apache 2.0 license, which means you can use it for whatever you want. Whether that's personal or commercial, does not matter. The only thing that I ask is that if you use it, say you used it. That's literally it. There will never be any sort of licensing or royalty fees of any kind. It'll always be free because it is an educational resource. And when I say that, it is a way to build a game engine. It's not necessarily always the right way or the only way to build a game engine. It's certainly not the only way to build a game engine. There's lots of ways to approach that, but we do lots of trial and error on this and trying a lot of different things to see what works, what doesn't, doing deep dives into those things. We do a lot of design work on here, and when we add a feature, we talk about it from beginning to end, including design and implementation. So that's basically what we're doing here. We've been at it for a while. The ultimate goal here is to make and release a game on Steam. And so not only are we building an engine, but we are building a game on top of that engine that is going to be released. So right now we're in the middle of sort of reworking how our 3D, what we're currently calling meshes, work. We are kind of in the middle of writing an animation system, an animated mesh system. And I kind of just had the thought, I'm like, we have static meshes, which, are just static in the scene. They don't move, they don't animate, they don't do anything. And then we have these animated meshes, which have, complex bone structures and vertex weights and all that good stuff, and animate. And the formats between those two different things were pretty close. And so I was writing the file format for the animated one. I'm like, you know what? This is kind of dumb that we have two different formats that are almost kind of the same thing. Let's think about a way to unify this. And so last stream, we kind of sat down and came up with this spec of a new format, a new file format for our animations, right? And we are combining sort of the static and the animation, animated meshes rather, into a single K3D, which is kind of what we're calling our new model format. And so what we have here is basically the specification for what that file looks like when we store it on disk. And so we've written we've written part of the deserializer for that. So that's reading the file in from disk, and reading in all of these buffers and all of that. And now we actually need to translate this into an actual asset that we can then use to upload the appropriate parts to the GPU and feed them into the systems that are required for rendering and things of that nature. And so we have, these K assets. We have this animated mesh sort of thing that we have here. And I was thinking, maybe we should probably not call it mesh anymore because this format refers to it as a model. And models can have submeshes, right? And so we designed this, we got this, we have all of this implemented in code, at least reading this bit out. And now we actually have to translate it into something in here that the rest of the engine can use. So we had this sort of animated mesh thing in here, and I'm thinking we're actually just going to actually change this to model. And so the type of asset we're going to be dealing with now is going to just be a model. So this is going to be, model, and then this will be model. And what I'm doing is I'm specifically not using the LSP to rename this because I want it to actually break everything that uses it. Because I want to go through and we're going to unify the two systems. So the animated mesh system and the static mesh system, we're going to unify those into a model system that then has these sort of static models and these animated models. And that's kind of what we're going to be, that's kind of what we're in the middle of now. Let's see. Let me back up and read some comments here. I think I'll try to switch from OpenGL to Vulkan for my 2D game. I don't think I'll need it, but I want to join the cool kids and should switch before I invest a lot of work in graphics. So 2D is probably one of those cases where I would say it's probably not necessary to switch to Vulkan. But you can if you want to, right? If you want to do it for the challenge and to learn the API, then absolutely go for it. Do you recommend any books for Vulkan or just online resources? So, do I still have it? I did have this book that I used when Vulkan first came out, which was the Vulkan cookbook, and this was okay. I don't know if there's a newer version out there, but there's VK Guide, that's way better. And of course the Vulkan spec is way better. So just reading the spec and understanding that. You can look at resources like Vulkan Tutorial, although I don't necessarily recommend the way that they do things in there all the time. But that is another resource. Another resource is anything. Look at Sasha Willem's GitHub. He's got tons of Vulkan examples out there, and I do mean tons. So have a look at that repo as to like how to accomplish different things. He did kind of build his himself like a little framework to abstract some of the Vulkan stuff, which unfortunately, I think was not probably the right move for somebody that's trying to learn how to use Vulkan, to have to sort of pick through those abstractions and see how the lowest level code is there. But regardless, they're very good examples in there. So yeah, I would just say stick to online resources because it's also it's actually changing quite a lot. Over the last couple of years, they've actually changed it quite a lot. For my NES emulator, CSTL project, I build the view with the CPU anyways, and then just copy the whole thing to the GPU and scale it up there. That makes a lot of sense, Puke. Yeah. That's probably how I would do it as well. 0x Cafe Babe is a great file type indicator. Yeah, so I'm probably going to wind up having to change it, actually, because somebody told me, and this is what you're talking about there, somebody had told me that apparently Java classes also use this, which I wasn't aware of. So, we can't be having that. So I'm probably going to have to change that. Vulkan for 2D sounds wild and so much work. Yeah, I would tend to agree. Unless you're doing it to learn the API, then it's fine. Don't know how much work it actually is. If it's only around a month of work, it would be fine. I care about the hardware handles things. I care about how the hardware handles things, rather. So OpenGL is a bit annoying. It's going to be more than a month of work, I can tell you that. It's not like you lift up OpenGL up and slide under Vulkan. It's not like that at all. Yeah, I mean, it's not crazy, but you're going to be surprised at how much it is. Yeah. Dead Beef is another one. I think Microsoft uses Dead Beef for stuff. So I think what I'm going to use, I actually have, a couple things in here. So I actually have the 32-bit one is Cafe Babe, but I actually have this other one in here, which is Cafe Babe Bad Coffee for a 64-bit one. So I might just stick with Bad Coffee. Which is kind of funny considering that the engine's name is Kohi. But yeah, I might do that. Diamond, I know what that one is. Yep. Dead Beef is classic, yeah, for sure. Should probably stick to curses. Fair enough. Yeah, there's a bunch of those things. I found a list with a whole bunch of things on it at one point. But yeah, bad coffee is one of my favorites. Oh yeah, there's also Xerox Dead Babe is another one. Yep, that's another one. Weren't kids making games in ASM back in the day? I heard about magazines that people I heard about magazines that taught people to make their own games. Pretty sure Carmack wrote a few of those magazine games. I don't remember if they were in ASM though. I feel like a lot of those magazines that had like the code samples were in like BASIC or something. Xerox decaf. Not enough characters, unfortunately. I could do bad decaf. That's actually kind of funny. Like Xerox. That's actually kind of funny. Or, you know what? Decaf bad. That's the one I'm going to use. Decaf bad. Yeah, bad coffee. Bad coffee I had in here, right? So I had Xerox Cafe Babe bad coffee. And I was thinking about using bad coffee, but decaf bad is actually pretty epic, I think. Wait, reread it. Oh, end curses. Wait, reread what? Oh, dead. Nope, I'm not getting that one, that guy. I'm not sure what that is. I guess I can't brain that tonight, I guess. Magazine games were mostly basic. Yeah, that's what I was thinking. Some might have short machine code subroutines. Yeah, I think for like performance critical sections, yeah. The ones I remember seeing were all basic. But maybe they had some ones that were fully ASM. I don't remember. Diomon. I'm not putting that one. That's very funny though. That should be an error code. Your NeoVim looks like a Fallout terminal. I could see that. Kind of, sort of. Reread my hex. Yeah, I was trying to reread it, but I'm not getting what it is. Dead feck? Yeah, I'm not sure what that is. Good thing you can't. Now we have much better hex. Yeah. Sometimes they'd have you hex chunks. Wait, sometimes they'd have hex chunks you had to type in with another basic program. Yeah. Bad code is another one, good one. Yep, I've seen that one. Oh, okay. Puke. I get it now. Yeah. Okay. I wasn't thinking about that. That does make sense. I've heard that before. It's just been a while, I guess. Let's see. For 2D software rendering would be fun. Yeah. Are the binary files self-contained or do they point out to other files on disk? They are self-contained. Yep. So one of the things that is in here is like anytime we, the only other thing that references to another asset is we have these material names. So this is a material name ID, which is a reference into the string table that's all the way at the bottom. And so you'd get a material name ID, and then that material would kick off, a material load, which would come from somewhere else. So yeah, it doesn't necessarily point to something else on disk. It's more of a reference by name, but yeah, that's kind of the way that works. You know what? Yeah, I'm going to change that. Let's see. That's going to be further up than I thought it was. Okay. We are going to change this to decaf bad. That's perfect. I like decaf bad. The only problem is we do have quite a few different things that use the asset magic. So we're going to have to like re-import everything if we change that, which I guess is fine. Our images use it. Our meshes use it. Our bitmap font serializer uses it. And our audio uses it. So that's going to kind of suck a little bit, but I feel like that is the right move. And I don't think we're ever going to use the 64-bit version. I think I'm just going to use that. This is worth breaking user space. Yeah, I tend to kind of agree. And we haven't done a major version release yet, so it's not even like we'll have to worry about backward compatibility at this point. Diamond. I'm not putting that one either. Why are we hexing? Yeah, I'm just trying to put I'm just trying to come up with a magic number to mark our assets as Kohi assets, right? So one of the first things, the first few bytes of the file are basically going to be marked with 0x decaf bad now. And that will basically say, yep, this is a Kohi asset, as opposed to some other file that we try to load in that does not have this. And then from there, we have other different checks like the asset type, which also probably shouldn't be K3D. That should probably be model. So let me change that. And do we actually have I don't know if we actually defined that anywhere yet. No. Wait a minute. Yes, we did. This should be model. Okay. So this just needs to be model. All right. Yeah, I feel better about that. That was really bothering me. Like when somebody brought up like Cafe Babe apparently is used by Java, and I'm just like, well, now it's kind of poisoned that I can't use it anymore. So yeah. Now it is decaf bad. I should probably put that in the ye old change log. Changed Kohi binary file magic number marker from 0x Cafe Babe to 0x decaf bad. This will require all assets to be re-imported. All right, just so I don't forget that in the changelog notes. Okay. So let's change all of these things to say model. So we'll do that. And then this is going to be what? Oh, almost had it. Okay, so model, and then this will be model as well. Yes, I know I'm doing this the manual hard way, but I'm looking to break things on purpose. Anything that's referencing this. Okay. And then we have animated mesh bone. That's going to be model bone. And then animated mesh node is going to be model node. And submesh data is going to be model submesh data, which I think I'm still fine with it being called a submesh. And then the animated mesh itself is just going to be model. And then all of these things are going to be model. And we're going to say a Kohi model asset. Sure. A model contains, or a model can contain mesh data, i.e. vertices, indices, bone, node, and animation data. All right. I think that's all of the renames. So that should be good. So now over here, we don't have this k-asset animated mesh anymore. We have model, which this is going to bleat because of what's in the header file. So this just needs to be model. And then this just needs to be a actually, I'm just going to say model asset. Okay. And then I guess we should probably rename these. So rename those. And then same thing there. And same thing here and here. And I know this is broken. We haven't gotten to it yet, so that's fine. Okay. So these are the internal K3D structures. We want to keep those internal to this because we're only going to use those when we are reading or writing to an actual file. The actual output of this is going to be this k-asset model structure here. And that is what we are actually going to build now that we've extracted all of this data here. So now we can actually say build out the asset structures. Martala, how's it going? Welcome. When will the volcano erupt? I mean, depends on the volcano. Depends on the volcano.
Slash bike shedding. Yeah. Yup. Unfortunately. It's just, if I do this wrong, here's the thing, right? Like I said, we already have two systems in here that are kind of already overlapping. And if I were to complete this as the direction I was going, we were going to make that worse. So it's like, I might as well just rip off the Band-Aid now, fix it, eliminate a bunch of duplicated code, and have both our static and animated meshes go through the same code path and use the same structures. Ideal would have been to do it that way from the beginning, but here we are. We didn't do it that way from the beginning, so. Is that like the Rust crate for Vulkan? Is that what that is? Okay, so the first thing we have to build out of this is we probably ought to build some of the stuff that we can pull straight from the header. So we can do out asset. I guess we could do animation counts equals header animation counts out asset bone counts equals header bone counts out assets node counts equals header node counts out assets submesh counts header submesh counts and then we can grab some other stuff like out assets center equals header center out assets extents equals header extents, and the global inverse transform is the last thing, I think. Oh, I didn't name those consistently. What a dingus. Okay. Doesn't matter, I guess. Okay, so the next thing that we're going to have to do is we'll have to create the arrays for each one of these things. I'm going to reorder these. I'm going to reorder these how they are in the file, even though I guess that doesn't technically matter here. I'm going to do it for my own sanity. So we have submeshes, and then bones and nodes, and then animations after that. Okay. So we'll take these two, put those there. We'll do out assets, submeshes, and that's going to be k-asset model submesh data. So we're going to do a k-alloc type C array, and that's going to be a k-asset model submesh data, and that's going to be out asset submesh count. This should only be done though if we have out asset submesh count. Otherwise, there's literally no point in trying to do that because you're going to allocate zero space, which is an error. All right, so we'll do this for bones, nodes, and animations. So bone counts, and then bones, and then this is going to be bone. And then this is going to be node counts, nodes, node, and then animation count.
You dingus.
Thank you for the follow. Appreciate that. Animations. And this needs to be animation. Okay.
You dingus.
So we've created all those, and then we'll have to iterate those types and actually fill them out with the appropriate data. Good night, and thank you for the follow. Appreciate that. H. Mendoza, how's it going? Good to see you. I'd like a game where a volcano erupts, no joke, as a simulation. Be definitely sell a few times, or a realistic diving game with realistic wrecks. I mean, it'd be kind of cool to simulate that as part of a game, I think. I don't know if I'd want to build an entire game around that, but like having an event with that would be kind of neat. Diamond, I will agree with you on that. The syntax, yeah. I agree with you on that, 100%. Okay, I think that's everything that we need to do here, so we can literally just process these one at a time. I am actually going to start with some of the simpler types. So I'm going to start with bones and nodes because those are the simplest ones. So what we'll do, I guess actually inside of here, I'll do a for you, actually, I just realized something else. That's a U32, but I think this is a U16 out of the asset. Yes, it is. Submesh count is the same. And I think these are all U16s. Yep. Not a huge deal, but I don't like having mismatched types like that. All right. So U16I equals 0. I is less than out asset bone count plus I. And then we can do out asset bones sub I. Let's see. I guess to avoid having to index these things so many times, because that's kind of annoying, we'll do a K. Wait a minute. Let me see. Oh, I might actually have to do it that way. Come to think of it. So let's say offset is equal to bones offset matrices I. Out. Yeah, I guess I could do. I could do this. That way I could just literally go like that. Bone ID is going to be just I. And then bone name. Okay, so this is where this string table comes into account, right? So this expects a name here, or a K name. But to get that, we're going to have to actually get a string first. So what we need to do is a binary string table entry. Or what was it? Get. I guess we could do a length. No, I'm just going to do a get. So the table is going to be string table. We grabbed that earlier. And the index is going to be bones, name IDs, sub I. And this returns a name, right? So then we could do name is kname creates name. And then unfortunately we have to do string free name. Now, I could just say maybe we only read so much of the name or whatever, and use the buffer option where we just have sort of a pre-allocated array that we read these names into. But I don't think it's really going to save us all that much time, right? This is, again, just reading in from this thing. So I think it's perfectly acceptable in this case to, read the name in this way, create a K-name from it, which also adds it to the lookup table, the global lookup table, and then just free it when we're done. But that's right there is all there is to loading from the data that we got from the file to the actual what the asset expects. All right. Let me see. Can Vulkan easily be processed with UE or Unity or something else? I hear a lot about Vulkan in the gaming industry, but I've never understood why. There's so much out there. Is it because it's tied to C and so many people like to do it with C? Yeah, so Diamond pretty much answered it. It's just a graphics API. It's like an equivalent of Direct3D, which you've probably also heard, or DirectX, right? Which is Direct3D's part of it. It's just another graphics API that is implemented by your graphics card driver, One option among others, depending on the platform. Yep, exactly. Unreal or Unity in the back end, probably use either Vulkan or DirectX or Metal to do rendering. Or, yeah, they definitely do use those. But yeah, that's all it is. And so people like to say, what's the, how does Unreal perform when it's using DirectX versus when it's using Vulkan, for example. That's what most people out there are talking about, unless they're actual graphics programmers who are aware of how that stuff works under the hood. What does this 3D format support? I was diving a little in GLTF and had my own 3D modeling support, or 3D modeling format ideas like RTS game Red Alert 3 with boneless animation and multiple UV models. So nothing fancy at the moment. So right now it's literally just your basic Vertex 3D, which is so we've got two different types of vertex data that we support. So for static meshes, these are what we have for now. It's just position, normal, texture, coordinate, color, and tangent. And then for a skinned Vertex 3D, it's all those things plus bone IDs and weights. That's all it is. Yeah, again, nothing too fancy yet. I plan on adding to this, though. It's not going to be anywhere near as complicated as GLTF by design. I want to keep this as simple as possible, and I only want to add what I actually need to it. Because why spend time adding things that I'm not going to use, right? But yeah. Modern graphics APIs are quite similar, honestly. Same but different. Yeah. Like Direct3D 12 is pretty close to Vulkan. Metal is kind of a departure from it, a little bit, but it's kind of got some shared similarities. But Metal and Web GPU, which is the browser equivalent of it, are very much alike from what I've seen. All right. I'm going to do nodes really quickly, and that's probably going to be the last one that I'm going to do for tonight. So I'm actually just going to, you know what, I'm going to copy pasta this. It's going to be mostly the same thing. We want node count nodes. And then this is going to be node. And we'll do node. And then the node wants a local transform. This is going to be nodes. Local transform sub I. This needs to be nodes, name IDs, and then parent index is the next thing. Okay, so parent index equals nodes parent indices sub I. And the child index of the children is going to be a little bit interesting, actually. So, and I might even want to move this out to a function, but I'm not going to do that for now. So we have this child count, and then we have the children, which are just indices into that, right? So we actually need to get a child count. So we're going to say node child count equals 0, which we don't really need to do, but I'm being explicit. And then what I'm going to do is I'm going to do for. We're actually going to have the same loop again. Right, but we're going to call it, we're going to use J this time. And the reason we need to loop through that again is we need to get a count. So we need to say if nodes parent indices sub J rather equals node parent, node. No, it's just going to be I, actually. Right? So if the parent index there is equal to I, then we're going to do node child count plus plus. And then down here, we're actually going to copy this again. We're going to do this one more time, but this is going to be if node child count is greater than 0. Right? So if it's greater than 0, then what we're going to do here is we're going to do kalloc CRA. The type is going to be U16, and the count is going to be node child count. And then that is going to be assigned to node children. Oops. Oops. I'm forgetting a, there we go. Right. And then what we'll do here is we'll say, we'll do one more U16 IDX equals 0. And we'll say if we have, if parent indices J equals I, which would still be true, then instead of doing this, we're going to say IDX plus plus. But before we do that, we're going to do node children sub J. Let me think about this for a second. No, sub IDX equals I. Wait, that doesn't make any sense. Let me rethink that. So we loop through all the nodes and we say if nodes sub j, if that's equal to I, which is the current node that we're on. Oh, this would be j. I was going to say that didn't sound right. It would be j, not I. And then we increment IDX. Right, so that's going to make sure it goes into the right index. And so that's how we are going to do that. Now, we could eliminate some of this looping if we use D-arrays, but I don't want to have to use D-arrays here because I want to be able to destroy these arrays as if they were created this way. I don't want to use D-arrays in a public interface like this. Let's see. Bedtime for me. Good luck. Yeah, it's actually going to be bedtime for me too. I ran a little bit over tonight, but that was by design. Had a little bit of extra time. So I think this is where I'm going to leave off. Extract vertex index data, etc. All right. So that's what I'm going to leave off for tonight because, yeah, it is midnight my time. So I've gone a little bit over what I normally do, but there we are. I'm going to search for somebody to raid. Before I do that, though, let me just, I see I've got a couple comments over here on the YouTube side I'll address. Say we had multiple bones and multiple weights for bones. Boils down to be able to program Blender and C++ in your own renderers. Yeah, I mean, so we don't actually have, one thing we don't have yet is blended animations. We'll be adding that in the future. But for now, we don't have that. So that is something we're definitely going to be adding. Alternate UV channels. I don't know if we're ever going to need that, so I may not add that, but yeah. All right. Yeah, let me find somebody to raid. While I do that, I just want to say thank you guys so much for joining and hanging out and interacting. It's been a pretty awesome stream tonight, I think, with that. So I appreciate that. And if you haven't already, I would greatly appreciate a follow either on the YouTube side or the Twitch side, or if you're so inclined, both, because I'm trying to grow my channel and I'm trying to encourage more people to want to get into some of this more low-level stuff and make game engines, competitor game engines to sort of the big three that are out there, because I think the more competition we have in this space, the better. It tends to drive ingenuity, and I think that's always a good thing. Let me see. This might be a bit of a challenge to find something that is similar to what we're doing, but we'll try. Let's see. All right, I think I know what direction I'm going to go, but I just want to have a quick scroll through who is online. So bear with me just 1 second here. Yeah, I don't think there's any any other C or C++ game devs on right now. Except Z.A. Shaw, but I think we rated him last night, so I'm trying to find somebody. Oh, you know what? Oh, okay, he's not doing game dev right now. Let me see. All right, I think I'm going to go ahead and go with... Wait a minute, where did it go? Yeah, we're going to go with Jitspo. All right. So yeah, that's going to do it for the stream. Thank you guys so much again for joining. We're going to go check out what Jitspo's up to. He's making a pretty cool retro FPS. It's a pretty neat looking project. He's got a lot of cool mechanics built into it. So we're going to go see what he's up to. And yeah, thanks guys for being here. And I'll catch you guys on the next one. See ya.